All right. So on Friday we talked about how there are instances that we want to see if one variable, the explanatory variable, produces a response in the response variable, okay, or the dependent variable, and we call that a correlation. Okay, so we want to see if and correlation, just a math term for relationship. Okay, and we talked on Friday that we could have things that, and these aren't the only representations, but these are the most common things that we're looking for. Okay, we're going to be looking for what we call a negative linear correlation here. Okay, this one here is a positive linear correlation. And now those are really strong correlations there. Okay, we might end up with a linear correlation that doesn't demonstrate the strength that these two demonstrate, and that's what we're going to kind of talk about. Is if we're just making a decision on what the scatter plot looks like, I could say it looks linear to me, and you could say that it looks like there's no correlation. And that's very subjective. So what we like to do is, can we put a number to it and let that number then be more precise for us? Okay. This situation here would be no correlation, because basically what we want to do in a correlation, a linear correlation, is as x is increasing, we see y is doing the same thing. Y is either increasing or y is decreasing. But from successive x's, it's really kind of showing the same pattern. But here, that's not happening. Here, as x increases, you get data points kind of plotted all over the place. Okay, so there's no pattern that can be realized. This is a nonlinear correlation. It's called a quadratic regression. So there is a parabola that could be fit between those data points. And once we have the equation, that parabola, we could use it to make predictions like we will with the linear correlations here. Okay, kind of went through towards the end of the period on Friday, giving you an example, just threw in some raw data into Excel and showed how it can generate a scatter plot for us. Okay, there's going to be instances where that's what they want. Okay, they want you to look at a scatter plot, make a guess at what you think the correlation is. Is it strong? Is it weak? Is it linear, nonlinear? And then they'll ask you to run through and actually do the calculations of the correlation coefficient. Okay, so the coefficient that we're talking about, the correlation coefficient, is that precision tool that allows us to state that there is a strong or a weak correlation between the variables. Okay, so the correlation coefficient is a measure of the strength and the direction of a linear relationship between two variables. Okay, it says the symbol lowercase r represents the sample correlation coefficient. Okay, there's something I'm not sure where it's at here. Okay, so the sample coefficient, like I said, is lowercase r, but the population correlation coefficient, because we'll talk about that here in a little bit, is the letter like that. Okay, that's the symbol. That's a Greek symbol. Does anybody know what that Greek symbol is? Kind of aligns with our R and our alphabet. Starts with R. You do it in a boat. Rho. Okay, but it's not spelled that. It's spelled R-H-O. Okay. So lowercase r is the sample, and rho here is the for the population. Okay, so that's just something to, because that's going to pop up here in a little bit. So here's the formula. Okay, it says you take your size of your sample, and you're going to multiply it by the sum of your data points multiplied together, minus then the sum of your x's times the sum of your y's. And you divide that then by the square root of your size of your data sample times the sum of your x's squared minus then the sum of x, square that. times in the square root and do the same exact thing for y. Okay. What that's doing is measuring something we call residuals. Okay, and we'll talk about that here in a little bit. So this value can range from -1 to 1, and it's inclusive. Okay, so this denominator will always be greater than the numerator. Okay, that's why you always get a number between 0 and 1. But if our data points, if this number here is greater than that number, then you're going to get a negative. Okay, so it could go from -1 to 0. So if x and y have a strong positive correlation, r is going to be close to 1. If they have a strong negative correlation, r is going to be close to -1. So it's perfect positive or negative correlation is when r equals 1 and r equals -1, respectively. Okay, and I would argue that experimentally, it's going to be very rare for us to get on the dot r equal 1, r equal -1. Okay, but if that does happen, then you have what we call a perfect correlation. Okay. So if there is no linear correlation or a weak correlation, then r is going to be close to 0. Okay. So when r is close to 0, it does not mean that there is not a correlation between the variables. It just means there is not a linear correlation between the variables. Does that make sense? So when we look up at this data here, if I were to take that raw data and run that through that formula, it's probably going to give you an r close to 0. And all that means is that there's not a linear correlation. There is indeed a quadratic correlation here. Does that make sense? Okay, so that would be maybe something that we have to investigate further. Once we realize that there is not a linear correlation, we say, okay, well, is there a quadratic, cubic, quartic, whatever? Okay. So these are some situations where, r is equal to 1 right here. Okay. R is equal to 1. That is a perfect positive correlation. Okay. You can see that is very linear, right? Okay. If you remember talking in Algebra 1, that is a direct variation equation. Okay. So that's very, I don't want to say very, that's perfect linear correlation. Here, you can see that as x is going to the right, y is steadily increasing, okay, consistently increasing. So you've got correlation here. You can put a line of best fit through here. And you can see that it's a strong correlation of 0.81. Okay. This one here, it looks a little bit more jumbled than what this one did, doesn't it? Looks a little bit less convincing that there's a linear correlation. Okay. When we run through things, we do get 0.45, okay, which is a weak positive correlation. Okay. So 0 is no correlation. 1 is a perfect correlation. So if you go halfway between 0 and 1, you're going to get a weak correlation. Does that kind of make sense? So like 0.5, maybe we can argue is maybe a threshold for being weak or strong. There's still going to be, and we'll use a hypothesis test to help with this, there's still going to be some subjectivity when we do this, because what's the argument? Okay, well, where's the breaking point for strong and weak? Does that make sense? Okay, so we'll use some testing to decipher that. Here we're working with a negative correlation, so there you're seeing a slope that is negative for the line. That's perfect negative correlation there. This one is a strong negative correlation. And then this one here, you can see that is very close to 0. Okay, so there's no correlation there. So those are the things that we would look for in a scatter plot. Okay, if I scatter plotted this, okay, some of you are going to say, oh, there's no correlation there. Okay, but through the calculation, we can say, well, there is correlation. It's just weak. Okay, and it is a positive correlation. So we are seeing that as x is going to the right, y is increasing, but it's not doing it as strong as maybe over here. Okay. All right, so what I want to do today is just kind of show you the different ways that we can find this number here. Okay, so we're going to use, I'm just going to pull out of a homework question that we're going to see, just some raw data. Okay, so let's go, let's see here. If you guys want to open Excel, and I'm going to type in just some headers here. I'm going to say age, and then I'm going to say vocabulary size. So the scenario that I'm going to give you here, it's going to take a handful of children, ages 1 through 6. Okay. Now, so the ages and years of 6 children and the number of words in their vocabulary. Okay. So the argument is, okay, so can we see, is there a linear correlation between how old a child is and how large their vocabulary is? Okay. They do this all the time with studies like this with young children whose parents read to them. Okay. And then they start to track vocabulary sizes for those children, and research has shown that there is a positive correlation with the sizes of children's vocabulary per that explanatory variable of length of time that they've been read to. Does that kind of make sense? Okay, which hopefully that kind of makes sense if a kid's, hearing words spoken from their parents, then out of a book, then that's going to increase vocabulary, right? But there's study that there's a strong positive correlation with that. So we've got this couple different ways we can build the correlation coefficient. So because we have knowledge of Excel, what I would like to do here, and there's going to be other ways of doing this, but I'd like to spend a little bit of time just trying to program Excel to build this for us, okay? Get more practice at that type of thing, okay? So what I want to do is I want to type in, let's find N first, okay? And let's let Excel do this to where N is going to be found without us actually having to count them. Does that make sense? Okay, so it's just going to go basically off of our input. So what I'm going to do here in C is I'm going to say, let's actually label this. Let's go N equals, and then over here in D1 or D2, I'm actually going to put the command here. I'm going to say equals, then I'm going to go count if. Okay. Now it's going to ask for the range. Okay. So what this command does is it's going to look through a range. It's going to look through a series of cells for us, and we want to go from A. We can do this 2 different ways. I'm just going to go A to A. I'm just going to say the whole A column, and then it says criteria. Okay. And I believe, and I might have to double check this, but I believe if I just put 2 things of quotation marks, that it will, as long as there's something typed into those cells, it will count it. Does that make sense? And that's not it. Let's see here. Let me see my. Oh. Okay. It has to be like this. There's two different ways of doing this. So it's like that. So you put the quotations around your less than symbol, right? Less than, and then followed by your greater than symbol and quotations. Hit enter, and it'll show me 7. Criteria is so it says count if, so that the range is obviously the place it's going to look, and then the criteria is what criteria is going to be met for it to be counted. Does that kind of make sense? So it's going to search through here, and it's going to say, okay, the criteria says, and now this is just a command for as long as there's something typed in here, count it. Okay, so it sees text, so it's going to count it. Okay, now that's one way of doing it. Another way is if I go count A. Okay, this is just a special count if command, and you just type in your range. It will also give you the same thing. Okay, so that's maybe a little bit quicker. But now look at this. So I just did the entire cell or the entire column A to A. Okay, and this is where you might have to augment formulas. Okay, you can change this because do I want this? So it's saying that it saw something in A1 and it's going to count it. Is that part of my data? Is that header part of my data? No. Okay. So you can change this by saying that you want to go from A2 through. I don't know if I hit through A that it's going to do anything. No. Okay. So if I do that, if I start with A2, then what I have to do is I have to somehow type in the last cell in that range that I want to talk about. Okay. Well, I don't know. I might come across a particular problem that has more than 100 things in it, or I might come across something that has more than 1,000 things in it, right? So I don't want to put limits maybe on myself and the amount of data that I can input. So instead of doing it that way, I'm going to stick with A to A. Okay, but can't I then, because I've got a header, subtract 1 from that? So it's going to count. It's going to see those 7, and then remove the header and give me 6. Does that make sense? Okay, so that's our N. The next thing we're going to do is find the product of X and Y. Okay, so let's go. I'm just going to write, and I don't know the way that seems best for this in regards to like the organization of our cells here. I think maybe I'm gonna do this. I'm gonna highlight those 2 that we just typed in. I'm gonna right click, hit cut, and then come up here in C1 and paste those. Okay, and you can see that what that does, it still uses the same formulas and all that kind of stuff. So cut and pasting doesn't mess anything up. And the reason I do that is because I want to take this value, because that's my X. Okay, so the age, think about this, is age dependent on vocabulary, or is vocabulary dependent on age? Say again. So if age is dependent on vocabulary, that means that based on my vocabulary, how big my vocabulary is, will dictate how old I am. Or is it the other way around? Okay, so age is the independent variable, and vocabulary depends on how old we are. Okay, so my age is my X's, and my vocabulary is my Y's. So I'm going to take in this column here, and I'm going to say X times Y. So it's just going to be easy to go that number times that number, right? Does that make sense? And that's X times Y. And now if I have that formula built in there, if I right click on this bottom right corner and drag it down, it should give me the product of all x's and all y's, right? Okay, now think about the things that we're interested in here. Okay, we want the sum of x times y. Okay, so we took all of our x's, multiplied them together with our y's, and now we want the sum of that. So I'm going to come up here and just type in sum of xy. And you can use, there's symbols in here that you can put sigma in there if you would like. Sum of xy. So that would be then I'm going to hit equals and then sum of C to C. Okay, and what that will do, even though that there is a header in that column C, it ignores it and says, okay, I know n equals is not a value to add, so it ignores it and adds those 6 values up. Okay, so you got the sum of xy. We need the sum of x's. Okay, so this one here, I'm going to say sum of x's. Remember, x's were in column A, so I'm going to hit equals sum of A to A. You can format those if you. I like to. I don't like that big gap between them, but so we need some x's. We also need a sum of y's. So sum of y's, and that was in column B. So I'll just say equals sum of B to B. All right. The next thing that we need, just double check. So we need our we need x squared. Okay. So I'm going to create. I'm actually so when I'm doing this, okay, and this is the nice thing about Excel. As I'm doing this, I'm trying to format this first time I've done it, and I realized I should probably maybe put in a column here that would have allowed me to take the x's and square them, and then the y's and square them. So what I want you guys to do is come up here between D and E, and you see how my cursor changes there? And I'm going to hit right click and see where it says insert. And actually, let's click on E first, because I think it inserts to the left. So click on this column and right click, go down to insert. You see how I put a column in there now? And what's nice, if you remember, okay, is so this had a formula in it, and because I inserted a column here, it's still referencing the correct things that I wanted. Okay, even if so let's look at this one. So, and this will mess things up theoretically, but Excel adjusts. This says the sum of B to B, right? Well, if I go in between A and B and I put a column in there, okay, this thing here is no longer column B, right? Okay, but that's my sum of my y's. Well, let's go back to this over here. Do you see how it changed now to sum CC? So it references, it knows that those are the things I wanted to add, and if somebody adds columns in there, don't let that column mess the formula up. Okay, so that's a nice thing. Okay, and you hit Control Z, you can undo that stuff. But this is going to be, I want to try to find x squareds. Okay, so then that's just going to be taking equals this column, and we'll square it. Once I have that, I'm going to drag down. and those are my x values squared. We need a column for our y values as well. So we'll take our y values and square those. As we do this, we drag those down. We're probably going to see, depending on how big your numbers over here is, they might start putting these things in scientific notation. That's fine. There's nothing, just kind of like that if your width of your cell is small. But there's a data value there, so that's really all we care about. We don't care what they look like. Now we need actually the sums of those things. So let's create another cell here, another column. Peyton? It's just B2 equals B2 squared, and then we drag that down. Yep. So we want the sum of x squared is going to be what I call the next column. So that would equal sum, and actually let's do it this way. All right, so after your y squared column, create a column G for x squared, the sum of that. And then in H1, we will actually add that up. So we'll equal sum of those. So it's and remember, I want this to be built so it will add up no matter how many data points I have. So I'm just going to say E to E. So sum those. Okay. I'm going to insert, I'm going to click on this column I, insert another. And now I want the sum of my y squareds. Click on J, insert another column. And here I'm going to hit the sum of F to F. So sum my y squareds. So I know that's a lot of stuff that we're adding together, but hopefully you realize that that's not, I think the biggest issue with Excel is not necessarily typing things in, but I struggle with organization, okay? I know it might look maybe like too many columns here. We could have put all of these things in maybe column I straight down. So I have like sum of x squared, sum of y squared, sum of xy, sum of, what's the other one, sum of x and sum of y, all in a column here. Maybe it look a little bit cleaner. Maybe we do that when we're done. But those components are built. Now we need this stuff here. Okay, we need the sum of x, not quantity squared. Okay, so let's just go to, just go over here and increase. Why can't I get to that next cell? I can't get to that next column for whatever reason. There we go. So we're going to insert a column here. Okay, so Q, I'm going to say sum. Actually, I'm going to put parentheses, sum of x, like this, and then square that. Okay, if you remember what that was, so we have, did we have the sum of x's? Did we add all the x's up? No, we didn't, right? Oh, yeah, we do. Okay, so we got sum of x right here as 21. Okay, so the sum of x squared will be 21 squared, right? So I'm going to hit equals, and we'll click that button or that cell right there, and then we'll square that. Yeah, we can. but I'm showing you what StatCrunch does. Yes. So this one here, it's just adding from A to A, and it's built in to recognize numbers versus, they call them strings, so it lists the characters. So it sees age and realizes that's not a number, so don't add it into the rest of things. So that's the sum of x squared. Now here, we're going to type in all right, so here in S, I'm going to hit sum of y squared. And that then is our y, sum of our y, with that number there, P1, and we'll square that. Okay? All right, so now what I want to do is I want to actually build the formula. Okay, so we've got all the small components to the formula. Now we need to build the formula. Okay, so I'm going to type in, I'm going to put the formula to the side here so we can see it. Get this thing to, there we go. So I'm just going to do this in H4. I'm going to hit equals. Okay. Now I'm going to put parentheses because I know I'm going to have a numerator and denominator. So open a parentheses. Now I'm going to hit n, which if you remember n was our value right here in what is D1. So I'm going to click on that and we'll automatically put that right there. Okay. Now we need to multiply that by the sum of xy. Well, sum of xy for us, you go find where it's at. Sum of xy is that number there. Okay. So coming back here, so right now we've got D1 times L1. Okay. We're going to subtract from that. Okay. Now I'm going to put a parenthesis here. It's the sum of x. I'm going to scroll through, find my sum of x. That cell there. And then times the sum of y. So you'll find y's sum, which is that number there. I'm going to close that parenthesis so that, those two parentheses around N1 and P1 are the two parentheses around these here. I'm going to put one more parenthesis to close off the numerator. And now I'm going to hit divide. Okay. And I'll open another parenthesis. We'll type in the command SQRT, stands for square root. And now I need a number. Okay, so the number is going to be n, which was D1. Okay, times the sum of x squared. Okay, so remember the sum of x squared would be this one here. Nope, not yet. Okay. So D1 times the sum of x squared minus now the sum of x, that quantity squared. So that would have been this one here in R1. Okay, now that R1 is the end of this square root. So I'm going to close that square root. Okay. Now I'm going to hit times, and now I need the square root of the second one. Okay, so n again, I remember that was D1. I'll multiply that by the sum of y squared, which we're seeing here is J1. And we'll subtract from that then the sum of y's squared and the sum of y's squared would have been T1. Found a typo in your formula, try to correct it. Usually when they do this, they're looking for, maybe I didn't put another parenthesis here to close off the denominator. So it's telling me that, click yes, and there's our positive correlation, okay? We'll come back tomorrow and talk a little bit more about that to start class. No homework.